You know, Greenland is 23 feet of sea level, 7.3 meters, if it all melts. And the history is very clear. When it was warm, there's no ice on Greenland. When it's cold, there's lots of ice on Greenland. And so it's very clear Greenland is very tightly tied to temperature. And if it gets too hot, it goes away. And too hot is not very many degrees above where we are now.
And this is the Ilulissat Glacier. This is the calving front of Ilulissat Glacier that we flew along on the first day. This is the fastest moving ice stream in the world. It's 400 feet high. The water is coming down under the ice and squirting out down here below the water line like a jacuzzi. And it's creating circulation down here, and it's drawing warm ocean water in underneath the water line here, and it makes it accelerate the calving off of the giant glaciers. And this whole bay here is just full of gigantic glaciers. As that movement accelerates, the ice upstream begins to crack and deform like this. And you can see as it cracks, that water begins to collect in those cracks. And that water begins to absorb more heat, and because water is heavier than ice, it actually begins to hydrofracture its way down into the ice sheet, accelerating the movement even further. So what you're seeing is that at every stage there is a different kind of a process that not only feeds on itself, but feeds into all the other processes in the cycle.
It's as if the entire lower tip of Manhattan broke off, except that the thickness, the height of it, is equivalent to buildings that are 2.5 or 3 times higher than they are. That's a magical, miraculous, horrible, scary thing. I don't know that anybody's really seen the miracle and horror of that. It took 100 years for it to retreat 8 miles from 1900 to 2000. From 2000 to 2010, it retreated 9 miles. So in 10 years, it retreated more than it had in the previous 100.